Happy Tuesday, Algebra 2. This is Coach Emmons. Today we're going to talk about operations with functions as well as compositions, and that's going to be the main focus. But we want to make sure that you understand this notation. So first of all, if you ever see something like this where it says f plus g of x, that equals f of x plus g of x. And basically this is just like adding polynomials, which is what you've already done in the past. They're just trying to confuse you. You know, mathematicians be trifling. It's fine. With differences, same concept, f minus g of x, and notice how I'm reading that, equals f of x minus g of x. Whenever you see these parentheses, that's going to be of as you read it, okay? So f of x. And then you've got product. So you're going to say f times g of x. So that's really just taking this function and multiplying it times that function. And then quotient, f divided by g of x is f of x divided by g of x. Okay? I don't want you to confuse this product. Notice how it has a closed circle with something that we're going to see a little bit later. So you got to make sure that you're paying attention to how it's written. Otherwise, you will mess this up. If you don't already have these written down, I would write these down in my notes so that I don't have any issues later on. But we're going to get some practice with this. So in our first example, we're going to take f of x and we're going to add g of x to it. Notice how it says f plus g of x. So we're going to take this stuff, we're going to add this stuff to it. So I'm just going to write it out in one big fancy line. Got 4x squared plus 6x minus 9 plus 6x squared minus x plus 2. And just like what we did in the last unit, we're going to combine our like terms. So we got 4x squared plus 6x squared, and that's going to give us 10x squared. And then we're going to add 6x minus x, and that's going to give us 6 minus 1, which is going to give us 5x. And then we're going to add negative 9 plus 2, which is going to give us negative 7. Negative 9 plus 2. Okay, and then this is all we have. Okay. On B, we're going to do something very, very similar. The only thing that's going to change a little bit is we're going to write the first function out. Okay, so we've got 4x squared plus 6x minus 9. And then we're going to say minus, and in parentheses, we're going to write everything that has g. Okay, and in the last unit, we saw this like this. We had parentheses around the first function, parentheses around the second function. With that negative, remember, you've got to distribute it out. Okay, so we've got that negative, and we're going to take it, we're going to share it with everything that's out here. So I'm going to rewrite this first function, which is going to be 4x squared plus 6x minus 9, and then I've got negative 6x plus x minus 2. And this is squared. Sorry. Okay, and just like in the last problem, then we're going to combine our like terms. And I'm sorry for that squeaker in the background, that's my dog. And then we've got 6x plus x, that's going to give us 7x. And negative 9 minus 2, which is going to give us a negative 11. Okay? So again, with the adding and subtracting, it's kind of like what we did in the last unit. They're just trying to confuse you on just really the notation on this. Now, if this would have said g minus f, f would come second, and that's the one that you would distribute that negative to. Okay? So just keep that in mind when you're looking at this notation. You got to pay attention to which one comes first. All right? All right, so let's look at this next one. It says f times g of x. So we're going to take f and we're going to multiply it times g. So how I would write this out is I would say 5x squared times 3x minus 1. Okay? So I'm going to multiply 5x squared times 3x, which is going to give me 15x cubed. And then I'm going to take 5x squared times negative 1, and that's going to give me negative 5x squared. That's it. Done. Next, we've got f divided by g of x. So we're going to take f, which is 5x squared, divided by 3x minus 1. Okay? Now, You could divide this completely out. Normally they just want you to write it like this, but sometimes they actually want you to put it inside the little house and like actually perform this division, that kind of thing. For right now, just leaving it in fraction form is okay. But one thing I do want to mention, notice how it says, be sure to state any domain restrictions. That domain restriction is actually going to come from this denominator. Back in the day, your teacher told you that you can't have a 0 in the denominator for any reason whatsoever. So if you had, for instance, 5 divided by 0, if you put that into your calculator, you're going to get something called undefined. Undefined. Okay? And undefined we don't like because it doesn't work in our functions. And since we're dealing with functions, we're not a big fan of it. So we want to make sure that in the bottom, the denominator, there is no 0. So we're going to take what's in the denominator, set it equal to 0, and solve for it. And I'll show you what that means in just 1 second and why we're going to do that. So we're going to add 1 to both sides. And then we're going to divide by 3 on both sides. So that's going to give me x is equal to 1/3. Now, if I take 1/3 and I plug it back into this denominator, that's going to give me 3 times 1/3, which is 1. 1 minus 1 is 0. Well, we can't have 0 in the denominator. So when they say state any domain restrictions, x cannot equal 1/3. Otherwise, this ruins this entire setup. So your final answer is going to be this fraction plus x cannot equal 1/3. You have to make sure that you put that little slash mark through the equal sign. Otherwise, it is wrong. So go ahead and take a moment and pause the video. Try these two on your own. Again, make sure that you state the domain restrictions on your division one. That's normally what's going to happen there. So take a moment, try it, and then check your work. All right. So on the first one, we're going to multiply. So we're taking 9x squared times 4x plus 3. So 9x squared times 4x, which is going to give me 36x cubed. And then we've got 9x squared times 3, which is going to give me 27x squared. That one's done. All right, on B, we've got f divided by g. So we got 9x squared divided by 4x plus 3. And again, sometimes you actually have to divide this out. And that happens from time to time. And so I would ask myself, how many times does 4x go into 9x squared? And I would say that it goes in 2x times. And then I would bring that down, or I would subtract, and then that would give me x squared. And I would put x squared over that 4x plus 3. However, most of the time for right now, it's going to be written like this, okay, like normally. But you're going to take what's in the denominator, set it equal to 0, and solve. And so that will give me x equals negative 3/4. But if I take negative 3/4 and I plug it in here, that'll give me 0 in the denominator. So x cannot equal negative 3/4. So this would be my final answer. Sorry, that's a 3. Okay, so hopefully that's pretty easy. If not, there's going to be some practice a little bit later, and we will revisit this. I've seen this on an SAT before, so you do have to know it. It doesn't go away. All right, so compositions. Compositions are really important. So right here, it says f composed of g of x. Okay, or sometimes we say f of g of x. Okay, that's how we read that. Okay, and it's really important which letter comes first. So you've got to make sure that you're paying attention, because down here you're seeing f of g, and over here you're seeing g of f. So those are two totally different answers. Okay, so in the first example, what's going to happen is you're going to start off by putting the first function down first. So you've got x squared minus 1 is your f, and 3x is your g. So we're going to write out x squared minus 1. x squared minus 1. Okay? And now I'm going to take what g is, and anywhere that I see an x in my f function, I'm going to plug that g in. So here it is again. I'm going to take that g function, which is 3 times x, and I'm going to plug it in for this x right here. Okay, so I'm going to get 3x squared minus 1. Notice how I put parentheses around that x. So now I'm going to simplify, and so I've got 3 squared, which is going to give me 9, x squared, which is going to give me x squared minus 1. Boom, done. Okay? So looking at the next one, the first thing that I'm going to do is I'm going to write the function g down. That's 3 times x. And now I'm going to take what is f and plug it in for my x in g. So I'm going to get 3 times x squared minus 1. And then I'm going to simplify. 3x squared minus 3. Okay, so really compositions is, hey, you have one function, plug the other one inside of the other one. That's how that works. So go ahead and take a moment and try number 5. Be mindful of that negative that's in both of those functions, okay? Take a moment, try number 5, and then check your work. Okay, so we're first going to take the function f, which is negative 2x squared plus 3. And we're going to take the function g, which is negative 2x, and we're going to plug it in for that x right here. Okay, so we're going to take this, and we're going to plug it in there. All right, so we're going to get negative 2x squared plus 3. So negative 2x squared is going to give me positive 4x squared. I've got that negative 2 chilling out front plus 3. So if I simplify this, I'm going to get negative 8x squared plus 3. Whoops, sorry. Okay, on b, we've got the function g, which is negative 2x. I'm going to take what f is, and I'm going to plug it in for this x. So I've got negative 2 times negative 2x squared plus 3. So I've got negative 2 times negative 2, which is positive 4x squared, negative 2 times 3, which is negative 6. Notice how I get 2 totally different answers. So if you're not paying attention to the lettering, it can cause you problems. Alright, so on number 6, we're basically doing the exact same thing. The only difference now is there's actually a number in here. Okay, so once you get to the end, you're going to plug that number in. So for instance, on the first one, we're going to write out what f is, and then we're going to plug g in for this x. So that's 3 times negative x squared minus 4. We're going to simplify, negative 3x squared minus 4. And then now we're going to take 2 and plug it in for the x. So this will give me negative 3, 2 squared minus 4. 2 squared is 4. 4 times 3, negative 3 is negative 12 minus 4, which is negative 16. So if you ever have a number here, you should have a number at the end. I would pause the video and try the next one. Okay, so we've got f, which is 3x minus 4. We plug in negative x squared, which is 3 times negative x squared minus 4. And then we're going to simplify, which is negative 3x squared minus 4. We're going to plug in 0 in for x. 0 squared is 0. 0 times negative 3 is 0. 0 minus 4 is negative 4. Alright, so down at the bottom of that page on eClass, you're going to try these problems. I'm probably going to have this posted a little bit later. But go ahead and try these problems on your own. Don't get caught up in the square root. Okay, the square root, just think about it, raised to the 1/2 power. That's how you want to think about square roots. Okay, good luck.